Hi, my name is Keenan Hardert. I'm a professor at Minnesota State University. I study cancer research and education research, and today we're looking at Prism's new power analysis feature. So you might know power as basically the test to see what parameters do I need before I start the experiment so that I know how certain I am I will get and catch a significant result. Let's say that the truth truly is that these two things are significant. So cool thing coming is that we can kind of run through different scenarios with different data types, as you can tell. Proportions and survival are upcoming, but let's just do an easy one with the t-test. So we want to say, hey, with this t-test, what kind of group are we going to look at? And then with what certainty are we actually going to get a significant relationship? Let's say that we, in the true metaphorical sense, the data were truly significant. Difference. Okay, so to begin, effect size is essentially a standardized way of saying what is the standard dev between, or essentially like what kind of spread do you need between the groups? In this case, you can use this right here and get going to significance. What you can also do is if you have more exact ideas in mind, what you can say is like, hey, so for my case in the education world, let's say that group one is this is what the average exam for most classes is assumed to be. And let's say that's like, yeah, that's the average for the class. If there was a second group out there, though, that was scoring a full letter grade below, so 10 points less, okay, let's take a look at that. If, for example, I wanted to say, and I can say assumed single standard dev or different devs for each group. Let's say that I would guess that the standard deviation of percent of exams in this typical group A is about 15. And let's say that over here in group two, I would guess they're a bit jumpier back and forth like that. Okay, so initially it's already going to auto calculate. You're probably following that number changing. Here's the effect size we're seeing. It's basically going to say, hey, we're already looking at about half a standard dev in that negative direction. So let's go ahead and get everything rolling. Sorry, I gotta be able to click here. Okay. So if I go to significance with this setup here, I'm going to keep this as two-tailed because again, one-tailed is making the assumption that it couldn't go either way, but two-tailed is the default. That's what you kind of want to do. In this case, again, 0.05, that's what you're probably looking for an alpha value. Now power. Here's where you can kind of change things. Point 0.8 is going to say 80% of the time, I will catch a significant difference if there truly was one. And then the other 20% of the time, we're not gonna. So we're gonna crank this up a little higher later. But for now, let's keep it at 0.8 and see what happens. This means right here that if I want to do this analysis and say that I do have a group B under whatever circumstances, and I do believe that or I think I see it incoming that they would be basically 10 points below, full letter grade below, it's going to say, all right, essentially for this amount and for the standard devs and everything that you put in for me, I'm going to need at least about N of 50 per group to achieve that level of power right there, to be that certain. So if we did something else over here, and again, the system's going to explain everything really nicely for you and actually kind of teach you a little bit about power and like all the scenarios that might happen, right? So looking over here, I promised I would. Watch the samples in group and what we need. If I say, I need to be more certain that I catch the true significance, up to 67 now, right? I need to be mega certain that I catch this. Here we go. So if I want to see a group A versus a group B and say like, why is a group B, are they actually lower by 10 points, a letter grade? I'm going to need a decently sized group, about 116 per, and that's what we're going to have to roll with. Now, the cool thing is you're not limited to these power amounts. If you go over here to the plot, and I'll show you this later, here's the total sample size, here's the power, and again, you can just kind of keep going and going and going because it is going to calculate these for you. And as we'll see later, eventually you get so much power that like adding more people it's not going to change past that really certain amount. But you also got a nice little table here if you want to kind of point and click and copy things like that. So we can move on these. Again, if I go to experiment design and say like, hey, let's do a one sample t-test in this case, group means, yeah, what the difference is, for example, again, this is going to simplify things. So if I'm like 70 as a pass and I want to say it's just going to be, 10 of a difference or something, Now we can kind of roll on the same idea here with a one sample t-test. It's going to do kind of the same idea and say like, hey, if you're even going to run a one sample t-test, that first sample, if you want at least 80% power and you're looking for to see a mean difference of 10 with a standard dev of 15, need at least 20. And again, if we crank that up, you're going to keep needing a higher N to be more certain that you truly do catch the significant value that you were looking for. So given over here, you can also run with paired t-tests. Take a look here. The only key difference here that's going to happen is, let's say again, I do my 70 versus my people that maybe they're not going to do well. And now I'm doing a paired, so like a before and after, or like on different tests type of things. And again, if I keep this here, keep that there, the only main difference now is that I'm saying like, I would guess that most people kind of keep the same exam score in this case. So I'm going to actually even make this pretty high right here. And you can see that expected effect value went up essentially, or at least got bigger in that negative direction, like we saw. So again, each time you run these, it's a good thing to do before you actually run the analyses to say, hey, if these are what I'm expecting or what I'm designing, how much am I going to have to put in to get to that point? So in that case, that actually wasn't as many. So I could probably be a lot more certain, like 99, and it's still going to say like, hey, if there is a true difference between these, it's going to catch them. Now, let's go back a little and just do a t-test again, run these. I think it keeps my numbers. Nah, it didn't, but that's okay. So let's leave the standard stuff in here. I can even say same standard dev, for example, and I'm going to say like 5 for these amount. Next to significance, let's calculate sample size. Okay. So right here, 17 per group. Perfect. We have the 80% power. Let's say that I was expecting whatever my mean over here was a lot bigger, right? See how that number just suddenly went down? Because if I'm saying that even with a group of 3, if that mean over here is like a lot higher than this one, and the standard dev is only 5, the effect size should be pretty massive because we're essentially saying like they're pretty far apart already. You don't actually need a high N to achieve significance and actually, or not to achieve significance, but definitely to like detect when its significance is truly there. And even if we get that even higher, yeah, 3 seems pretty good. So you can also do this with ANOVAs, for example. You're just going to say how many groups essentially. I could say like, here, I want this many groups. This one's assuming the same standard dev. But I think what I would say is, yeah, so if I want like 4 groups, I'm assuming that, or I'm going to say like, hey, what am I going to take if I only have like this much difference, 5 between each group, and now let's say 10 between each group. Let's say these are 4 exam takers, maybe. That's a lot of variance, actually, 5 between. But you can take a look here, calculate sample size. Yeah, again, I probably gotta, here, I'm gonna put this down a little bit. There we go. And let's kind of run this. Wonder if I can do, yeah. I'm just making it too easy for the ANOVA to run in this case then. Yeah, the standard effect size is huge in this group. So maybe I would do like a 2 there and like a 1. And no. Yeah, I guess I lowered it a bit, but when the time comes, you can sort of mimic what you would propose for an experiment so that you know in the future I'm going to have to do this new setup. And that should allow you to have a lot of like flexibility. Well, should allow you to give you some guidance on like what to look for, what to expect, or kind of like to set things up before you actually run through things. So, thanks for watching.